So last time we have seen how to take the partial derivatives of functions, that is first order partial derivative. Now we'll see higher order partial derivatives. Higher order partial derivatives. Higher order partial derivatives means what we have to do here, we have to, that is what second order, third order partial derivative. That means we have to differentiate the first order derivative, first order partial derivative with respect to x or y partially with respect to. Suppose this is what, this is your fx, and we want to differentiate this with respect to x now. This is nothing what, dou by dou x of dou f by dou x, dou f by dou x. So we'll write this as limit. So what we are doing now, you are differentiating partially, differentiating fx partially with respect to x now. Now this is your f now, fx is your f now. So you have to increase your x coordinate of this. So that means what, this is what we'll write, this is what ab at. Just we'll see the formula for ab. So this is what fx a plus h b minus fx ab upon h. So to evaluate the second order partial derivative, so what you have to do, you have to first evaluate fx a plus hb with your usual formula. You have to evaluate fx ab with your usual formula. You have to put the values of fx a plus hb, fx ab in here, and then you have to evaluate the limit now. Now this is the second order partial derivative. Now this is y now. This is ab. That means what, we are differentiating fx partially with respect to y. So this is what, dou by dou y of dou f by dou x at ab is equal to limit. We are differentiating with respect to y now. So we will take k tends to 0. And we are differentiating fx with respect to y. That means we have to increase your y coordinate of f of x, fx. You have to increase your y coordinate now. This is k minus fx ab upon k. Now, so what we have to do here, we are differentiating fx with respect to x, fx with respect to y. Now fy with respect to x now. So we are differentiating with respect to x. So this is dou by dou x of dou f by dou x at ab is nothing but what, we are differentiating with respect to x. So limit h tends to 0, right? We are differentiating fy. So your f will be what, your fy. So fy a plus hb minus fy ab upon h. Okay, so now, so fyy now, fyy at ab is nothing but dou by dou y of dou f by dou y at ab. So we are differentiating fy partially with respect to y. So limit k tends to 0. So limit k tends to 0, fy a b plus k minus fy ab upon k. Right? So these are the formulae to differentiate first order derivative with respect to x and y, partially with respect to x. That means this is the second order partial derivative. These are called second order partial derivatives. Similarly you can write this is what, fxx. What you have to do, this is your formula, right? So fxx you have to differentiate this. So how we can write this is what, limit h tends to 0, fxx a plus h b. This is your formula, right? So fxx ab. We are not interested in this formula, but just we will write this. Just we are differentiating fxx with respect to x. So fxx a plus hb minus fx ab, right? So in this way you can differentiate what, fxx with respect to y, fxx with respect to z. So for z you have to take, here. Okay, doesn't matter. This is what two variable, doesn't matter. Fxx y now, fxx fxy y, and so on. So this is what the third order partial derivative. This is nothing but what, third order partial derivative. We are not interested actually in the formula. We have to take the third order partial derivative, but not in by using this. So we'll take some problems so that you will understand to take the problem. Calculate f x x y z if f of x y z is equal to sine of 3x plus yz. Okay, solution. This is what fourth order partial derivative. This is the fourth order derivative. So what we will do here? First we will find fx, then we will differentiate with respect to x, then we will differentiate with respect to y, and then we will differentiate z now. Okay, solution. So given that f of x y z is equal to sine of 3x plus yz. Okay, so first we will do fx. Right? First we will differentiate with respect to x now. Fx. So this is sine of something. Derivative of sine of something is cos of something. Into derivative of something is what? 3. Okay? So this is nothing but what? 3 cos of 3x plus yz. Okay? Again, what? We have to differentiate with respect to x now. So fxx. We have to differentiate this. You know that the derivative of cos is minus, so we write minus. Now the 3 will be as it is, right? And derivative of cos of something is what? Minus sine of something, so minus we have taken this, what? 3x plus yz into 3. So this is minus sine 9 of 3x plus yz. Okay? Now what we have to do? We have to differentiate with respect to now. Now we will differentiate this with respect to y. Partial differentiation. So fxxy. So again this is 9. So now this y is there now. Okay? So y is there. So which what? This is what? Minus 9 cos of 3x plus yz into derivative of something with respect to y now. So derivative of 3x is 0. Derivative of yz is z now. This is what? Z. So this is what? Minus 9z cos of 3x plus yz. So this is your what? fxy. Now we have to differentiate with respect to z now. So fxyz. Now see here. There is z and here is also z. That means this is the product of two functions. Right? So you have to apply the product rule. So first we will keep 9z and minus 9z as it is. Then we will differentiate this one. Right? So first we will take minus 9z. So you know that the derivative of cos is minus. So minus minus become plus now. This is what? Sine of 3x plus yz into derivative of something with respect to z now. So this will be your y plus cos of something as it is into derivative of minus 9z into derivative of minus 9z with respect to z. So this is minus 9. So your answer is what? So therefore fxyz is equal to what? 9yz cos sine of 3x plus yz. Then this is minus 9 cos of 3x plus yz. So this is your answer. Now we'll take the next example. Find all second order partial derivatives. Problem is what? Find all. So find all second order partial derivatives of f of xy is equal to x cube plus x square y cube minus twice y square minus twice y square. We have to find all second order partial. There are 4 second order partial derivatives, right? Okay, solution. Given that f of xy x cube plus x square y cube minus twice y square. So first we will find fx. We will find fx. We will differentiate fx with respect to x and y. Then we will find fy, and we will differentiate that fy with respect to x and y. So we get all the 4 partial derivatives, second order partial derivatives. So this is what 3x square plus twice x y cube. Derivative of twice y square is 0. Now fxx what 6x plus 2y cube. Now fxy we have to differentiate with respect to y, partial differentiation. So this is 0. So this is what then 6xy square. Right? Now we will find f with respect to y now. First order partial derivative with respect to y. So we have to differentiate this with respect to y now. So derivative of x cube is 0. So this is what 3x square y square minus 4y. Now what we have to do? We have to differentiate fy partially with respect to x and partially with respect to y. So first we will differentiate partially with respect to x now. So this is what 6xy square. Right? Derivative of 4y is 0 because it is constant. Now we have to differentiate this with respect to y now. Fyy. So fyy we have to differentiate with respect to y. This is what 6x square y minus 4. Right? So this is the first order partial derivative, second order partial derivative. This is also second order partial derivatives. Right? These are the 4 second order partial derivatives. Find all second order partial derivatives. Fxy is equal to x cube y raised to 5 plus 2 x to the power y. What do we have to do? We have to find all second order partial derivatives. That means what? We have to find 4 second order partial derivatives. So solution. Given that this is your given, right? So first we differentiate with respect to x, and then we will differentiate this with respect to x and y. We get the 2 second order partial derivative. Then we will differentiate with respect to y, and we will differentiate that fy with respect to x and fy. So we get the all 4 second order partial derivatives. So this is what 3x square y raised to 5 plus. Now here what we are differentiating with respect to x. That means your y is constant, right? So power is constant. So you can pull the power and reduce the power by 1 now, right? Okay. So now we will differentiate with respect to x. This with respect to x, so that we will get a second order partial differentiation. Right? Okay. So this is what 6x y raised to 5 as it is. Then twice y as it is into derivative of x to the power y minus 1. Again y minus 1 is constant, so y minus 1 x to the power y minus 2. Right? Now we will differentiate this with respect to y now. This with respect to y. Right? Okay. So y to the power 5 is there. So this is what 15x square y to the power 4 now here. Plus. So now here you have to apply the product rule, because this is a function of y and this is also a function of y. So this is the product of 2 functions. We need to apply the product rule. Right? So we will apply product rule. So your twice y as it is. Your twice y as it is. We differentiate this. Now your base is constant. Your base is constant. So it is of the form a raised to x. And what is the derivative of a raised to x? A raised to x into log a. So your a is your what? Your a is what? X now. So this is what? X to the power y minus 1 into log a into derivative of y minus 1. Right? So derivative of y minus 1 is 1. Right? Okay. So this is the first part now. Right? Then you are what? X to the power y minus 1 as it is into derivative of twice y. That is 2. Right? So that is your f of, so we will write this one, 15x square y raised to 4 plus twice y x raised to y minus 1 log x plus 2 into x raised to y minus 1. Right? Okay, so we'll get the with the help of first order partial derivative with respect to x, we get the 2 second order partial differentiation. Now we will differentiate with respect to y, and with the help of the first order partial derivative with respect to y, we will obtain the 2 second order partial differentiation. So we will write fy now. We differentiate with respect to y, partial with respect to y. So this is what 5x cube y raised to 4 plus 2. Now your y is constant. Y is not constant. We are differentiating with respect to y. Your x is constant. So this is of the form a raised to x now. So a raised to x means what? X raised to y log x. Right? Now we will differentiate this with respect to x now. Y x now. Right? Okay. So we are differentiating. This is what? A 15 x square y raised to 4. Now this is the product of two functions. Right? Okay, so what we will apply product rule? 2x to the power y as it is. Derivative of log x is 1 upon x, right? Plus 2 log x as it is. 2 is constant, log x to the power y. Derivative of x to the power y, right, into log x. Just we will simplify this. This is what? 15x square y raised to 4 plus 2 y minus 1. This is what? X to the power y upon x is nothing but x to the power y minus 1 plus 2 log of x bracket square. This is log x, that is log x. X to the power y. Right? So now we'll differentiate this. This is your fy. We'll differentiate this with respect to y now. So fyy. That is very easy. Fyy. So this is what? 20 x cube y cube plus 2 plus 2. Derivative of x to the power. Log x is constant now here. Right? X to the power y is what? X to the power y into log x into log x. So log x square. Right? Double log x there. So we get up all 4 second order partial derivatives. So I hope that you understand this, right? So this is just like an one variable, right? Only I have to take a care. Only I have to take the care of the other variable. Okay, so we'll take the one more example. If w is equal to root of u square plus v square, u square plus v square, right? So what we have to do? Your variable x and y, instead of x and y there are u and v. So we differentiate with respect to u. We differentiate again with respect to u. We differentiate with respect to v. We again differentiate with respect to v. Right? So solution given that w is equal to, so w now. This is what? Root of something. So derivative of root of something is 1 upon 2 root of something into derivative of something. So into twice. Now your 2 get cancelled. So this is what? U upon u square plus v square. Now what I have to do? We have to differentiate this with respect to u and this will differentiate with respect to v. So this is what? First we differentiate with respect to u. Now see that your numerator is a function of u, your denominator is also a function of u. You need to differentiate with respect. We need to use u by v rule. So first your denominator as it is. Your denominator as it is into derivative of numerator is 1 minus numerator as it is into derivative of denominator. This is what? 1 upon 2 u square plus v square into twice u upon the square of the denominator. So square of the denominator what? The root get cancelled only. So we will simplify this. So what we will do? This is what? 2 get cancelled, no problem here. We will multiply this side, or we will multiply by root of u square plus v square to all the terms of the numerator and denominator. So what we will get? This is what? U square plus v square minus u square upon u square plus v square to the power 3 by 2. Right? So this is half and this is 1. 1 plus half is 3 by 2. So this will be your 3 by 2. Now this will what then? V square upon u square plus v square to the power 3 by 2. Now this is your WU. Now UV will differentiate this with respect to V now. Now see here what? So this we will write for our simplification u square plus v square to the power minus half. Okay, to differentiate this. So now we are differentiating with respect to V. So that means what, your u is constant. Only this is the function. So no need to apply the product rule now. Right? So u will be as it is. Then the full your power, just we will write in bracket half. Then reduce the power by 1. So this is minus 3 by 2. Right? So into derivative of u square plus v square with respect to v. So that is twice v. You have to take the care of this one. So this is what? These two get cancelled. This is minus uv upon u square plus v square to the power 3 by 2. Right? So this is your second order partial derivative. Right? Second order partial derivative. Now we will find third order partial derivative. So what we will do there? We will differentiate this with respect to v, and then we will differentiate with respect to u and v now. So we will differentiate this with respect to v. So actually if you interchange u and v, so we get the same thing actually. Okay, so we'll check this. What v, this is what 1 upon 2 root of u square plus v square into twice v. So this is v upon root of u square plus v square. This for second one, so we'll write this what minus half. Okay, doesn't matter if we will directly represent. We'll instead of using u variable directly we'll use the product rule, right? So that also we can do. This is what WVU. We will differentiate this with respect to u. Now this v is constant. Now this is a function of u. Only we have to differentiate this. No need to apply the product rule. So your v as it is. Power minus half. Pull the power minus half. So this is what u square plus v square divided to the power by 1. So this is minus 3 by 2. Into derivative of u square plus v square partially with respect to u. So this is twice u. So again your 2 get cancelled. Now see it is same now. So WUV is same as WVU. So UV upon u square plus v square to the power 3 by 2. Okay? Now we differentiate this with respect to u v now. So WVV. Again use the product rule. So last time we for the second order partial derivative, so what we have applied u by v. We have differentiated this, right? But now we'll differentiate it. We'll use the product rule. So v as it is now your. So this will what then minus half. So u square plus v square to the power minus 3 by 2 into derivative of u square plus v square partially with respect to v now, right? Partially with respect to v. So this is what twice v plus u square plus v square to the power minus half as it is, right? Into derivative of v is 1 now. It's 1. So what is this then? Minus this is it. Minus uv u square plus v square to the power minus 3 by 2. So how we can write? Okay. Okay. So plus this is what u square plus v square to the power minus half. To the power minus half. Okay. So what we will do here? So if you take the common, common is what here? How which minus half you can take common. This is what? Okay, we will write first. This is what uv to u square plus v square to the power into this is power minus 1. Okay, that write a minus 1. Okay, so this is what minus uv upon u square plus v square to the power 3 by 2 plus 1 upon, so actually no need to simplify this, minus half, so it becomes plus half. Okay, so what is your LCM then? This is your LCM. So this is what? Minus UV LCM. So if you multiply and divide by u square plus v square, if you multiply by this is what? U square plus v square, so we get this 3 by 2. So plus u square plus v square. This is not uv, this is v square. This is twice v. This put to get cancelled. This is what? V square, not uv. This is v square upon u square plus v square to the power 3 by 2. So your v square get cancelled, and we get what? U square upon u square plus v square to the power 3 by 2. And for that, for VU, so what we get here? U square, here what? V square we get, right? So now here we get u square. So we are correct. So Z is equal to e raised to x e raised to y. Now see, this is a function. See, e raised to x into e raised to y is there. Okay, it doesn't matter. So Z is equal to, we'll directly differentiate this. So dou u by dou z by dou x dou z by. We'll use this notation for your convenience. Okay. So differentiate with respect to, this is what? E to the power something, e to the power something as it is, into derivative of something. So your derivative of something is e raised to y, right? Again we will differentiate with respect to z. It will be denoted by dou 2z by dou x square. It is denoted by dou 2z by dou x square. For notation, so instead of this what? Z x we write this also. So this is what? E raised to x e raised to y into e raised to y e raised to y. So this is e raised to x e raised to y into e raised to y square. Or you may write this is what? E raised to twice y, right? So this is what? X e raised to y e raised to twice y. Because what? Power of power is nothing but product of the power. Okay, so we get this second order operation. Now this is what? Dou 2z by dou y dou x. We differentiate this with respect to y. Now see, this is a function of y, this is also a function of y. We have to apply the product rule. We will keep this function as it is, e raised to y as it is, derivative of e raised to y, e raised to y. Now we put e raised to y as it is, this e raised to y as it is, we will differentiate this. So this is what? E raised to x e raised to y into derivative of x e raised to y, into derivative of x e raised to y. So x as it is, derivative of e raised to y is e raised to y, right? So take the care of this one. We have to differentiate this what? X e raised to y. This is e raised to something, right? E raised to something is e raised to something into derivative of something. Something is your what? X e raised to y. Now we have to differentiate x e raised to y partially with respect to y now. So constant will be a derivative of e raised to y is e raised to y. Actually again this is you have to apply e raised to something. So but this is y. So no need to write here derivative of y now because it is 1. So if it is e raised to twice y, then this will be 2 will be here, e raised to twice y into derivative of twice y will be there, right? Okay. So we'll write this. So we'll take common this what? E raised to x, e raised to y is common. We'll just simplify this. So e raised to y as it is now here, plus x e raised to twice y, e raised to x, e raised to y into e raised to y is what? E raised to twice y. Actually we'll write here what? If the base is same, then you have to take the product, then only take the sum of the powers. No need to actually write this what? This steps, no need to write this. Okay, so this is right. Now what we'll do? We'll differentiate this with respect to y, and then we'll differentiate with respect to x and y, so that we'll get the second order partial derivatives. Okay, so what we'll do? Now we'll differentiate this with respect to y now. Dou z by dou y. So we are differentiating with respect to y. Again this is what? So this is what? E raised to something. So e raised to something into derivative of something. So something is your what? X e raised to y. and derivative of x e raised to y is what? E raised to y, right? So this is your dou z by dou y. Now we'll differentiate this with respect to x and with respect to y now. So dou 2 z y. First we'll differentiate this with respect to x now. Now see, this is a function of x. This is also a function of x, right? So e raised to y is not function of y. So we'll take this, right? So x into this. Now we'll apply the product rule. So x will be as it is. We are differentiating with respect to x. Note that. So x will be as it is. E raised to x, e raised to y into derivative of something partially with respect to x. So this is what? E raised to y. E raised to y plus. Now your what? X x e raised to x e raised to y as it is into derivative of x. So this will be. So what we write? E raised to y into e raised to x, e raised to y. We have taken this as common. So x e raised to y plus 1 now. Yeah. So this is your second order partial derivative with respect to x now. Now we'll differentiate with respect to y now. So this is what? Dou 2 z by dou y square. You have to write, right? Okay, so now we have to differentiate this with respect to y again. Now note that this is a function of y, this is also a function of y, right? So we have to apply a product rule. X will be out, right? So write in the bracket, because what, there are two terms. So if you are applying the product rule, then there are two terms. So you do that in the square bracket, right? Okay, so we'll keep this as it is. We'll differentiate it with respect to this function with respect to y now. X e raised to x, e raised to y. So derivative of e raised to y is e raised to y. Now your e raised to y is as it is. Second function as it is, derivative of the first function. You have to differentiate this with respect to y now. So e x e raised to y into x e raised to y. Derivative of this one with respect to y. X is constant. The derivative of e raised to y is e raised to y. So now see which we can take the common. So x e raised to y we can take the common. Again e raised to x e raised to y also we can take the common. So what we get here? It is 1 plus. So we have taken this as a common. This is also common. So x e raised to y. So if you are able to take the common, then and then only take the common. Otherwise keep this as it is. Right? Don't do anything, because question is not show that. If it is show that, arrange the term. Okay, so we'll take the problem. Okay, so w is equal to z e raised to x y z. Okay, we'll take this one, no problem. So we have to find all second order partial derivatives. So what we have to do? We'll find wx, then differentiate that with respect to x, with respect to y, with respect to z. Find wy, differentiate that wy with respect to x, with respect to y, with respect to z. Find wz, differentiate that with respect to x, with respect to y, with respect to z. We get the second order differentiation. So this is what. Now we write this wx. Okay. So this is what, z is constant. This will be as it is. E raised to x y z is nothing but what? E raised to x y z into y z. Into yz. So that is what? Y z square e raised to x y z. So now we'll find wy now. Xx. Okay. We'll go to the second order differentiation. Right? Then we'll find that y. We differentiate that wy with respect to x y z. Then we'll find wz. Then we differentiate that wz with respect to x y z. We get the second order partial derivative. So we'll do only this. So other thing, I hope that you can do at home. Right? Okay. So we have to differentiate with respect to x now. Note that this is constant. So no need to use no need to apply the product rule now. Then e raised to x y z. Again this is what? Y z. So this is y square z to e raised to x y z. Okay, now we'll differentiate this with respect to y now. So for y, wx square difference. So y, you have to apply the product rule, right? So z square will be common because it is constant, and we'll apply product rule for this one only. So y will be as it is. We'll take the derivative of the second function now. So this is with respect to y now. This is xyz into xz plus e raised to xyz into derivative of y is 1 now. So this is what z square e raised to xyz plus 1 or 1 plus xyz, doesn't matter, right? Now we differentiate with respect to z now. Now z, we have to differentiate this with respect to z now. Again z square is here and this is also function of z. We have to apply the product rule for this to z square and e raised to x0. Now your y will be constant, your y will be at the outside the bracket. Now we differentiate this with respect to z. Your z square is as it is. Then e raised to xyz. That's what? E raised to xyz. We are the partial derivative of xyz with respect to z is your xy. Plus, now e raised to xyz as it is into derivative of z square is twice z. So which one will be common? Z is common and e raised to xyz is common. So yz e raised to xyz common. So this is what is xyz. xyz. So this is common. So plus 2. This is plus 2. Right? So similarly, you can find wy, differentiate that wy with respect to x, with respect to y, with respect to z. Right? Then find wz, differentiate that wz, partial with respect to x, partial with respect to y, partial with respect to z. Right? So I hope that you can solve this problem at your own. Okay? So we will stop here.